Ladies and gentlemen, welcome to Plenary Event number 9, Achieving a Sustainable Space Environment for Future Space Activity. My name is Ray Williamson, Executive Director of Secure World Foundation, and we have a stellar lineup of speakers for this event, which is sponsored by the International Academy of Astronautics, the International Institute of Space Law, and the Space Security Committee of the International Astronautical Federation. The plenary event was organized by Secure World Foundation. First, we'll have as a speaker Dr. K. Kasturirangan, former director of the Indian Space Research Organization and now member of the Planning Committee of the Indian government. Next, we'll hear from Nick Johnson, Chief Scientist for Orbital Debris at NASA Johnson Space Center, followed up by Dr. Sergio Camacho, Director General of CRECTEALC in Mexico, an organization affiliated with the UN. It's a regional center for teaching science and technology in Latin America and the Caribbean. And finally, last but not least, will be Guy-Uwe Schrogel, Director of the European Space Policy Institute in Vienna, Austria. We will hear from each in turn and then open the floor for discussion. First among themselves, as I am sure they may have questions of each other or comments, and then we'll open it up for broad discussion. Today is particularly devoted to peace. At first glance, it may be hard for some to see the connection between peace and outer space, but in fact those connections are very close. In the Cold War, the use of orbiting spacecraft helped keep the peace between the two great powers. Today, powerful communication satellites in geosynchronous orbit help bring people from distant lands together in commerce, education, entertainment, and other peaceful activities. Earth observation spacecraft provide crucial data about environmental changes on Earth. Position, navigation, and timing satellite systems make it possible for emergency services to locate the homes of injured or sick people quickly and efficiently in times of need, or to locate distressed individuals after natural disasters. We gain many benefits from activities in outer space. Yet, today, we, as you heard from this morning's lecture, we face a near-Earth space environment that is on its way to becoming unusable as a result of both intentional and unintentional incidents that have left thousands of pieces of debris in space. The population of satellites is also increasing, particularly in the key sun-synchronous and geosynchronous orbits, and we face a future in which some have urged the development and use of weapons that could cause even more debris in Earth orbit. So the talks we're about to hear will illuminate some of these issues we face in assuring the long-term sustainability of space activities. And I just want to draw your attention to a very recent publication. It was just introduced 2 weeks ago. This is the Space Security Index. We've put copies out on the ends of the rows. This is produced by the Plowshares Foundation in Canada and puts together the incidents over the last year that relate to space security. So it reviews all the space activities that have any relation to it at all. And finally, I will now turn to Dr. Kasturirangan for his remarks.
Thank you, Ray, and good morning. First of all, I would like to express my grateful thanks to the organizers for giving me this privilege of addressing this morning on a very important issue, that of cooperative approaches to the long-term sustainability of space activity. And I have been particularly asked to focus on the international framework that could promote that kind of an objective. Sustainability of space activities, of course, there is two components: the sustainability of environment and the sustainability of the activity itself. And when one talks of sustainability of activities, one is talking of increased financing of the space activities, creation of better and increased infrastructure, and of course enlargement of the human resources base. And in this connection, at least one can think of three broad directions in which the future of space activities could evolve. One, of course, is the consolidation of the present activities, one which relates to creating better institutions to bring the use of space to a larger cross-section of the humankind. Certainly, this is something, at least in our country, I am aware, there is much scope in terms of institutional framework being improved so that better utilization of the space is possible. And expansion to the new stakeholders. Of course, if one looks at across in a map of the world, the level to which the space is used in different parts of the world, there is still quite a lot of countries, regions and agencies which could play a better role in terms of increasing the space utilization. So there is direct expansion possibility which could also be an important component of a long-term sustenance. And of course, one could think of newer dimensions for the space in international cooperation. For example, is the space station is ready? Can more countries participate in the utilization of the space station, including India? And of course, collaborative framework with increasing level of activities in planetary exploration, lunar bases, and future of mankind with respect to the exploration and expansion of space activity. There could be newer dimensions of international cooperation, which could be an important component of sustaining the space of the future. A specific area which one should keep note in this connection is the commercial space activities. The commercial space activities certainly has today it has overrun the government investments. In fact, it is growing and is today much more than the government spending. And of course, civilian uses and military uses both encompass this kind of a growth. And they operate in a global environment. What one talks of global environment is the ownership of the space systems, the control of the space system, and the provision of services. They have a global character today. So when you talk of this kind of a global character, obviously one has to look at the existing international space law, the need to fine-tune some of these systems in the context of the growing use of space by a number of countries comes into picture. Domestic laws of dominant players. Of course, there are issues with respect to the easy availability of space services, even for civilian purposes, when it comes to the questions which are related to non-proliferation or questions which are related to whether it will be used properly or improperly. The definition, of course, is a little vague. But these are things on which one has to address whether one can have a sustained support in terms of the space services to countries which do not have the full space system, and whether it can be cost effective and it can be efficient. And ultimately, many countries have domestic laws. They need harmonization with respect to this changing global scenario. Now let me come to the specific area of space debris. Of course, we had an excellent speech in the morning. I don't want to say much about that, except two or three important things which in my view probably could be taken up in the future. One is today the space system tracking and providing a catalog is primarily resting with the United States capabilities. Could there be in an international cooperative framework a regional and global consortium in the context of tracking and removal? This is something which one can start thinking about. But when you talk of regional or global system, obviously there has to be investments, there has to be technology availability, and there has to be an operational sustenance. So these are the kind of things that one has to address. Removal of GSO satellites, I don't want to get into this, I'm sure that somebody else would also speak about it. And ultimately, the debris control measures to be made obligatory, the questions of the various laws that are being discussed, the regulations that are being discussed in the context of debris control measures certainly need to be brought in. What one talks of here is national efforts in the control of debris control for what you are responsible under an international supervision, not very different by like the framework of an ITU. The other important thing is with respect to the arms race in space. Certainly this is a major concern, can affect the sustainability of space activities in future, offensive uses, which can considerably on one side increase the debris population. Any testing of weapons in space certainly has to be banned, and the fallout affects all. In this connection, certainly one has some very interesting developments that has taken place in the context of this. After 12 years of stalemate, the Conference on Disarmament Working Group recently has been revived. And then you have the UN corpus now discussing the policies related to the sustenance of the space. There is a question of code of conduct. This is now being seriously discussed in the international fora, and what is gratifying to note that the EU currently is seriously pursuing this, and one cannot also overlook the statements that Barack Obama made, the President Barack Obama, in the pre-election campaign regarding the need to re-examine the US position with respect to the weaponization of space. So these are some of the things. Now let us look at some internationally coordinated common research agenda. What I am trying to do is to put together a set of agenda in the area of research, which I think is extremely important ultimately for many countries to play an important role with respect to the questions of sustainability of environment of space. There are many technologies which one has discussed. In fact, in the morning lecture, one could hear a very articulate presentation of the various concepts and techniques. Here are a few of them that is mentioned here. The most important thing that I want to mention with respect to, these are only examples, but it is not fully exhaustive. But what I would like to emphasize is it is necessary that various groups take over this responsibility and carry out researches. There is a good exchange of the outcome of the research, and ultimately also the key to the whole research outcome is the fact that you share the output from these research programs. The internationally coordinated program is the complementing strategy that one can think of. There are several global missions today which addresses global issues, global concerns. So typical examples are the disaster management support, monitoring of the global change, environmental and meteorological satellite mission. Is it possible for the countries to get together, discuss the question of an optimized approach to the carrying out of this mission, ensure that there is a requisite number of satellites, but not more, not less, and also bring in people or countries who can be also playing a useful role in this kind of a system? I think this could play on one side an optimized approach with respect to the global missions for issues of global concerns, and on the other side it is also opens up some possibility with respect to countries which otherwise today has no role in some of these major areas of concern on a global scale. And therefore I conclude currently with an international responsibility. Is it not time to set up an international forum, maybe under United Nations, to foster a secure environment to ensure sustainable space activity for future? When I say this, I have in mind things like IADC, the Interagency Debris Control, which has evolved by itself into a forum, a very effective forum. The output of this has been placed to the United Nations. The United Nations has adopted this as a guideline. So there is an excellent example of the way these things can evolve. So on a global basis, a better understanding, coming together, and then try to discuss in a forum, and then ultimately convert them into conventions, treaties, or laws, whatever it can be, to ensure that we have a sustainable space for sustainable activities of future. Thank you.
Thank you, Dr. Kasturirangan. That was excellent contribution. Oh. So while he's picking up his notes, let me say that this morning has been a very interesting morning. Those of you who came in a little late missed an excellent talk from Nick on the iridium collision, and now he will amplify some.
Okay. I don't need it. It's automatic. While the adage, what goes up must come down, still applies in the space age, satellites normally take a very long time to fall back to Earth. and in many cases, the descent can take hundreds or thousands of years. After more than 4,600 missions conducted worldwide since Sputnik 1, a large number of man-made spacecraft has accumulated in Earth orbit. Thus, the numerous operational spacecraft, such as the human-occupied International Space Station, which is currently circling the globe, performing vital functions of communications, navigation, Earth observation, science and research, exploration, defense, are accompanied by a much larger population of defunct spacecraft, derelict launch vehicle orbital stages, intentional refuse, and the products of more than 200 satellite explosions and collisions, as can be seen behind me. Now, I do need to make one caveat here. For obvious reasons, the debris is not to the same scale as the Earth. But this type of illustration does give you a good indication of the growth of the number of debris and its distribution around the Earth. Today, the United States Space Surveillance Network is tracking more than 20,000 individual objects in orbit about the Earth, of which approximately 95% represent orbital debris. However, these are only the larger pieces of debris, typically 10 centimeters or more in diameter. At the level of 1 centimeter, which is still potentially hazardous to any spacecraft in current Earth orbit, we believe the number approaches 500,000. Due to the tremendous energies possessed by these space debris, the collision between a 1 centimeter debris and an operational spacecraft, be it a human-piloted craft or robotic craft, has potential for catastrophic consequences. Since 1988, the United States Space National Policy has specifically addressed the need to limit the growth of orbital debris. The current National Space Policy, signed by President Bush in 2006, charges U.S. government agencies and organizations with seeking to, quote, minimize the creation of orbital debris by government and non-government operations in space in order to preserve the space environment for future generations, end quote. In 1995, NASA was the first U.S. government organization to establish formal space debris mitigation guidelines. In 2001, the U.S. government orbital debris mitigation standard practices, based upon the NASA orbital debris mitigation guidelines, was adopted after a lengthy and thorough intergovernmental review and coordination with the aerospace industry. The fundamental elements of these standard practices were adopted in 2002 by the major spacefaring nations under the auspices of the Interagency Space Debris Coordination Committee, whose members represent the space agencies of 10 countries as well as that of the European Space Agency. In 2007, the United Nations, through the Committee on the Peaceful Uses of Outer Space, adopted a similar set of space debris mitigation guidelines. For 35 years, from mid-1961 to mid-1996, the population of cataloged space objects in Earth orbit increased at a rate of 270 per year. However, with the concerted efforts of the major spacefaring nations, the rate dramatically dropped to only 70 per year for the remaining or the following decade. Unfortunately, the intentional destruction of the Chinese Fengyun 1C weather satellite in January of 2007 and the accidental collision of the American and Russian spacecraft in February of this year increased the catalog population by more than 40% in comparison with all the debris currently in orbit since the beginning of the space age. The recent collision of two intact satellites underscores the NASA finding that the amount of debris already in Earth orbit is sufficient to lead to more accidental collisions, which in turn will lead to an unintended increase in the number of space debris and an increased risk to operational spacecraft. In the future, such collisions are likely to be the principal source of new debris. The most effective means of limiting satellite collisions is to remove non-functional spacecraft and launch vehicle orbital stages. In December of this year, the United States government will hold the first international conference on orbital debris removal. However, the remediation of the near-Earth space environment presents substantial technical and economic challenges. The threat posed by orbital debris to the reliable operation of space systems will continue to grow as the sources of space debris continue to grow. The international aerospace community has already made significant strides in the design and the operation of space systems to curtail the creation of new orbital debris, but more remains to be done. Thank you.
Thank you very much for those important words about what needs to be done for the future. And next we'll turn to Sergio Camacho, Director General of CRECTEAC in Mexico.
Thank you very much, Ray. I'm going to be talking of one particular area of promoting the sustainability of space activities. The situation, or I shouldn't use that word because I'll use it in a different context in a moment. The issue has many, many facets, as you have probably seen throughout the symposium, and you have seen some of them this morning. But I want to focus on one in particular. Our current goal is to promote cooperative international space situational awareness to achieve a sustainable space environment for space activities. Our ultimate goal is to ensure a sustainable access to and use of outer space in accordance with international treaties. And we have to take many actions in order to achieve this ultimate goal. I'm not going to speak about the spacefaring countries, but rather about emerging space countries and about those that will surely follow in the near and midterm future. Now, the fact is that space is becoming crowded by spacecraft and satellites. And there are a number of actions that we can take or should not take in order to prevent this from growing, from getting worse. The demand for the services and the benefits that we get from space is only going to continue. On one hand, we're very happy to see that the technology can be used to resolve problems on Earth and to promote sustainable development in developing countries. Many of these are the emerging space nations of today. In looking at why countries are getting more into space, I see two things. One, the technology itself is becoming more accessible in terms of cost. And at the same time, the benefits are increasing. This combination promotes that developing countries are putting in more resources into space activities. Some of them as users and some of them as what we are now calling emerging space nations. Practically every country has access to a variety of space services through commercial satellites, communications through Intelsat, Inmarsat, and so. Meteorological services, practically in every country, you see the use of imagery from the weather satellites. The use of GNSS is also becoming ubiquitous. You find that in almost every country, at least in cars, local transportation, trucks, trucking, shipment, and in some instances in aviation. All this derives in a benefit for the countries. As a result, many of the countries in Africa, in Asia and the Pacific, and in Latin America are becoming newcomers to the space stage. The development has been at different paces, but nevertheless it keeps growing. Several new actors have launched capabilities or are about to achieve launch capabilities. Now at present, there must be somewhere at least 10 to 12 countries around the world with recently established space agencies or commissions, or that are in the process of establishing one. And I think the number that I mentioned is probably on the conservative side. As legislation usually follows policy, the focus, in my view, at present, with respect to space emerging nations and those that will follow, should be on strengthening the capacity of emerging space countries to develop their national space policies. The situation that we have, in my view, presents a unique opportunity to engage high-level policymakers to highlight the importance of developing a space policy that supports national development programs, current and future, while ensuring that the resulting national policy is aligned with the outer space treaties, which means starting off on the right foot. The responsible use of space is another issue that is receiving growing attention by the international space community. Countries with space assets have a stake in maintaining the sustainability of space activities, and this includes many of the space emerging nations. There are countries like Venezuela that have recently placed their first communication satellite. Bolivia will be shortly, in the next 3 years or so, doing the same. Colombia has plans right now. There's a bid out for tenders for a communication satellite. Nigeria has placed a communication satellite and a remote sensing satellite. So the number of space emerging nations is increasing. The fact that national space policies haven't been developed, on one hand, tends to hold them back, perhaps in the use or the better use of those resources. It may also hold them back in terms of the international cooperation that they could be achieving if they already had their space legislation. But on the other hand, it provides the opportunity to have that national space policy aligned with the international treaties and with such things as the principles on space debris mitigation or the safety framework for the use of nuclear power sources. And whether their particular use of any of these is in the future, the policies would lead eventually to the legislation, and it could make the difference. As you recall, the space debris mitigation guidelines are voluntary. However, they could be made mandatory, and some countries are already doing that, at the national level. If countries that are establishing right now their space policies and later their space legislation were to adhere in their policies to some of these internationally agreed guidelines and frameworks, the future of the space activities that they themselves conduct would probably be in accordance with the developments that will have taken place at that time. I believe that the exchange of information among emerging space countries on their space policies or on the rationale driving the development of a space policy has a twofold benefit. On one hand, shared experiences are a capacity-building tool for countries at an earlier stage of development of their space policy. On the other, the awareness of the information shared could lead a country to include elements in their space policy that they might not have included otherwise. Both of these benefits would contribute to a more responsible use of space. In concluding, I would say assisting emerging space countries to develop their space policies such that they are aligned with the UN outer space treaties and encouraging their adherence to internationally agreed guidelines and frameworks is an investment to promote good practices and the long-term sustainability of space activities. And thank you very much for your attention.
Thank you, Sergio. And then finally, we'll hear from Kai-Uwe Schorgel, Director of the European Space Policy Institute.
Thank you very much, Ray.
This is the next page.
Yes. Thank you for inviting me to this plenary to present an activity we recently conducted last year as a workshop organized by the European Space Policy Institute, ESPI, together with the Secure World Foundation and the International Academy of Astronautics. Sustainable use of outer space. It's an idea, it's a concept, and it's also a vision. But what is behind it? How can we make it operational? And what are the principles on which this concept should be based on? We picked two such principles where we think that they might be crucial in achieving the sustainable use of outer space. And these two principles are fairness and responsibility. The fair and the responsible use of outer space, an international perspective, was therefore the title of our conference, which, as you can see here, was held in Vienna at ESPI in late November last year, organized, as I said, together with IAA and the Secure World Foundation, with the participation from all continents. We had speakers from Latin America, Asia, Africa, US, and also from Europe, providing a broad perspective of ideas, of concepts, also of policy approaches, and a common idea of how to make sustainable use of outer space an operational concept. And in the course of this conference, we realized, well, we could agree, at least us, the non-governmental people, we could agree on an approach. And this approach we laid down in a small brochure we called the 10 Steps to Achieve Fair and Responsible Use of Outer Space. And I will briefly run through a number of points we mentioned here, which are the core of such a concept we could and should apply in order to have use of outer space which is sustainable and at the same time reflects the needs of all the users of today and of tomorrow. The first point, which was mentioned in particular by representatives of developing countries, but it's also true for all other spacefaring nations, that it is that a holistic view on the role of space-based solutions have to be taken when it comes to the question of why do we use outer space, for what purposes. And here we don't speak about the sustainable use of outer space, but the use of outer space for sustainability. And we identified areas like environment, resources, security, knowledge, mobility, as well as energy, which are crucial for the progress of societies on Earth and of the international society. Data sharing in this context is one of the prime goals when it comes to the fair use, and here we are again in the question of how fairness can be implemented. Then, number 2 and 3, we can put that possibly together. We will have to enhance the use of space in international organizations. And this is particularly true for the UN system, the organizations in the UN system, but also in other space or space-related international organizations or user organizations, possibly leading, and this was the idea of the chairman of UN Corpus who participated in our meeting as well, leading to a UN space policy. We then, and this is also a question which is related to what the UN system and UN Corpus in particular could do, is that we have to strengthen the implementation and application of a harmonized legal regime. And we have heard from the previous speakers that regulatory measures are important for an orderly conduct of outer space, but we will have to encounter and face that currently there is a discrepancy in the development of regulation on the international level, on the regional as well as the national level, but we have to maintain and come to a regulatory environment which is harmonized, so that there is a level playing field, that there are no flags of convenience, which we know from areas like maritime traffic, to have that also in outer space. And now we turn in the last points to the real question of how to make the use of outer space function also in the future. We will have to have in the future consultation mechanisms, decision-making procedures, and also, because this is missing so far, we have to have enforcement mechanisms on the international level in order to make the rules really and actually work. And we have to involve everybody. We have to involve operators as well, not only the states. And this is one of the aspects, the key aspects of fairness, to provide opportunities to all the players, to all the actors, and to do that in a way that everybody can have a share and an opportunity to participate. And then, and this is maybe the concept, the big concept for the future, space traffic management. Sooner or later, we have to face that the way space activities are organized right now on a legal basis of states as the prime actors and a few launches here and there, that we will have to overcome that. We have to apply a new concept for space activities. And this will be to look at space as a traffic system. For this purpose, the International Academy of Astronautics a few years ago has issued a cosmic study on space traffic management, and after that a number of further studies and initiatives have emerged in order to refine that concept and to come up with new and additional ideas. But this is a real, true new approach and concept for the use of outer space, which can and should be taken into account when it comes to the question of how to achieve sustainable use and fair use and responsible use at the same time. Then the last points, we have to protect the space environment. We have heard that from Nick Johnson. What is going to do? We have to also, and this was pointed out by Dr. Kasturirangan, that we have to look also for space debris remediation, not only mitigation. And we have to see that we protect the planetary environment as well. The frequency spectrum has also to be used in a fair and equitable manner. ITU is the organization to do that, and they have already prepared and produced rules and procedures which could also be adoptable in other areas of space activities. The avoidance of an arms race, it's not only an ethical but also a political need which has to be more forcefully to be considered, and initiatives like the EU Draft Code of Conduct might lead out of the blockages which we currently have in the international fora. We then also have to create mechanisms, and this was a point which was raised by Sergio Camacho. We have to create mechanisms which allow emerging space powers and also the non-spacefaring countries, the very latecomers, to participate and to provide them with the benefits space applications can and should have for international society. And the last point, and this is something we should also mention and stress continuously, the next generation, the young generation, should also have its say in shaping and, let's say, looking into the future of the organization and governance of outer space. And right before the Congress, the Space Generation Advisory Council held its annual large conference and reported about these activities also during IAC. And these are starting points for having a look into the ideas, the concepts, but also the wishes and demands of the next generation. So these were the 10 steps we came up with in order to provide some meat and flesh to the idea of how sustainability could look like. And as I said, we put that under the two principles of fairness and responsibility. Thank you very much.
Thank you, Kai-Uwe. And now I think, given that we've got about 15 minutes, that we'll open the floor immediately to questions from the audience. And then if there's time left, I have a couple of questions for the panelists myself. But are there questions? Oh, you can, there are some microphones. Let's see, there's one, two, at least. So raise your hand if you have a question. I can't believe there are no questions. Yes, sir.
I've been to many, many conferences like this, space conferences, and every year senior policymakers like yourself agree that we should have some formal policy that not only mandates but forces people to use space properly and to mitigate space debris. My question to you is, why is this so difficult to bring about?
That's a very good question. Let me start with Kai-Uwe on that one, since he had the floor immediately. Yeah, just a minute.
Yes, the question of why we cannot achieve more easily on rules and international arrangements which are really enforceable as well as binding in the field of space debris, I understand. Now, the international mechanisms of arriving or for arriving at such binding rules and enforceable rules are currently focused around the work and the way the United Nations Committee on the Peaceful Uses of Outer Space is conducting its business. This committee has been able to draft a number of binding international treaties during the 60s and 70s, but then in a, let's say, 2-decade-long period wasn't able to arrive at binding agreements, but just developed rules of procedure, or let's say to a lesser extent enforceable things like UN General Assembly resolutions. We then saw the development of, let's say, clubs. The clubs of countries, agencies, which really were concerned and which really drove specific issues, and space debris was one of these issues. It was the IADC, which was composed only of the countries which had launching or have launching capabilities, and which are the ones who are the really concerned actors in this field, which came up with technical guidelines and rules. And this was a mechanism which provided the international forum, the intergovernmental forum, with a good basis for their deliberations. But the international community is still not in a position to, let's say, return to the period of the 60s and 70s when they were really able to draft binding norms through international agreements, but remains still in the thinking of simply looking into the opportunities of guidelines which are non-binding. We see that in a number of other areas as well, missile proliferation, for example, but also in the field of Earth observation, data use, and others, that the international community, the governments, are currently not in a position of agreeing on binding norms in almost all areas of regulating space activities. So we have to be satisfied with these lesser binding norms we currently face in a number of areas, and we have to possibly overcome this situation by a new concept of how to regulate and how to approach the regulation of outer space activities. And this is what I mentioned when I said space traffic management. Space traffic management will be crucial in the future as a concept of how to regulate space activities, where we then will be able to integrate all these points: frequency management, data policies, space debris mitigation, remediation, and a number of other regulatory issues and problems in a broader framework of how to use outer space and how then to regulate on different levels the use and specific aspects of the use of outer space.
Thank you, Kai-Uwe. Dr. Kasturirangan, would you care to comment on that question that was asked?
Yeah, first I should say that any things which becomes an ultimate treaty in United Nations is a very painfully slow process. If really from guidelines to conventions and guidelines to policies to conventions to treaties is a process which we have experienced over the decades. This is simply because of the fact that, many of these questions related to debris regulation is regulation of the space activity. The space activity regulation is intrinsically connected with broader policies of the use of space for multiple purposes. And unless a nation has a clarity about what is those multiple purposes, civilian, military, and many other aspects, I don't think that they can come to a conclusion as to how to deal with a policy or a treaty that stems from it. So that is one aspect of it. Notwithstanding this, I should also mention that countries like India, which has a launch capability, which has a satellite capability, we have already adopted many of the guidelines that has been provided for under the, for example, IADC, for example, the passivation of the vehicle, the research on the passivation of the upper stage of the launch vehicle, the questions of seeing whether the communication satellites, we should lift it out of the orbit, say 300 kilometers, and what kind of fuel penalty we pay, on what kind of commercial implications it have. I think these are all being very well addressed, very seriously addressed. So to me, I think it is going to move in a certain pace, but during that pace, many of the nations which are concerned with it will certainly adopt these guidelines and demonstrate to the world that they are serious about it, and maybe at that particular point, a treaty becomes feasible.
Thank you very much. I think the bottom line is that in our international regime that we are currently under, the state-centric international regime that requires all these agreements and treaties require acceptance to be bound by the given states, and it's sometimes very difficult to explain to the state in such a way that the officials agree that it is necessary to be bound in order to move forward. And so it seems to me that that's our role in part as professionals in the space business, to help that happen for the long-term sustainability of outer space. But let's see if there's some other questions here. Yes, sir.
Thank you, Ray. You just mentioned, and earlier had mentioned, long-term sustainability. I'm curious as to what the panelists think should be used in terms of number of years, 10 years, 30 years, longer, for purposes of doing policy analysis and cost-benefit analysis.
Huh. Thank you. Nick, have you got a thought about that?
I'm not quite sure I understood the question. We do both near-term and far-term analyses with cost-benefit in mind. So maybe if you could repeat the question, I'd be in better shape.
The issue is if decisions need to be made regarding what actions to take, as in any business decision or any other kind of policy analysis decision, one needs to understand how far into the future the effects of that action need to be studied. So you might choose a different course of action if you're only looking out 5 years than you would if you're looking out 10 years or 30 years or longer. So my question is, what do the panelists think, what do we in the space community think, should be recommended as guidelines for those cost-benefit analyses? Does that make sense?
Well, I think it depends upon the issue at hand. Many of the policies that we have right now relate to actions which have immediate effect. Immediate effect in not creating debris or near-term effect in limiting the accumulation of debris. On the other hand, we look, as you well know, we talked about earlier this week, we look into the future, decades, if not longer, to see which mitigation measures, for example, in the area of space debris, are most effective. It is clear that we don't want to spend a lot of time and effort and resources into actions and designs which are not going to be the most beneficial.
Thank you. Sergio, would you have a sort of policy-related answer to that? You're involved in the policy activities in Mexico and Latin America in general.
Well, I think more than looking at a specific issue, which might be space debris in the immediate future, whether you have a fixed number of countries that are going to be contributing to it, or you expect to have an amount that's twice as large, or whatever it might be, the number might be. What's important is to establish trends, and the trend has a time projection that you might then extrapolate to and see if this trend continues, then what is the situation going to be at such a point? I think this is the way the analysis is usually put forward. And what we're trying to do is to see if we can have an effect on that trend. And the feedback might come in the previous presentation. Before the panel started, Nick was indicating how the number of events that created space debris came from 200 or 200 and some to about 70. So the trend was going up, and yet by a single action, which might take place over a period of time, that trend reversed. So before the policy was taken or the action was actually put into effect, if one had projected, one would have said, well, by this year or in 10 years, we're going to have 400 or 600. But that changed practically overnight with the action that was taken. Now, the other side is, how long did it take to come up with that? First, based on research, to see, can we change it significantly if we do this? So it's a question of identifying what might have a large effect, a positive effect, or negative effect. And once that is done, having agreement among those that are involved the game. And once that happens, then we have that immediate effect, or almost immediate. Nothing is immediate. I don't know if that answers a little bit. What I'm trying to say is the time frame over which an analysis is made is variable depending on the situation, the issue that is being looked at.
Thank you very much. And Kaiuwe wanted to make a point, and then I have one more question out here, Kaiuwe. So.
Yes, when we talk about periods or trends, I would say the next 15 years, we can pretty well assess what will be happening based on the long-term plans of the space agencies, of the operators, and also of the policies and plans we currently have. But then after 15 years, then there will be a next phase. This will be prepared right now, and we will certainly see new types of space activities. Space tourism might take ground and be developed further on. We will have new satellite systems, certainly, and we will have new policies and plans. We will have new actors. We will have new emerging space powers. And this is, I think, the threshold where we also have to have new policy concepts of how to organize space activities. So 15 years from now, this will be still, let's say, something predictable, but following then, we will have to see into new concepts and then also touch the problem of sustainability. How then can we further sustainability? We have to lay groundwork now, talk about such principles like fairness and responsibility, try to operationalize them in order to be able to find policy concepts for this phase to come after 2020 or 2025.
Thank you. And then one last question. I think Mark Williamson has a question here.
Thank you. Mark Williamson, Space Technology Consultant. Given the recognized issues and problems with debris in Earth orbit and ensuring the sustainability of Earth orbit, what does the panel think are the chances for sustaining a similar sustainability in lunar orbit? I'm thinking towards the future, as you just have been doing, possibly in the next 10 years when there will be a growing lunar infrastructure of communication satellites, GPS-type satellites, and so on. And therefore there's bound to be eventually a debris problem. Do you think we can learn from the problems of Earth orbit and look forward to protecting lunar orbit and beyond that, of course, Mars orbit?
Thank you. And Dr. Kasturirangan, oh, I'm sorry. Well, let me take Nick first and then Dr. Kasturirangan, if you don't mind.
Actually, at NASA a couple years ago, we expanded our space debris mitigation guidelines to include not only the Moon, Mars, but also the Lagrangian points.
Wow.
It turns out that the Moon itself is has very unstable orbits. So it's actually very easy to see a future which does not have a large orbital debris environment about the Moon. But that doesn't mean that we don't have to make smart decisions in how we dispose of our spacecraft in lunar orbit or stages in lunar orbit. And so within NASA, we have already addressed that issue.
Can you pick one crater?
Yeah, I think we are on the threshold of a new era of lunar exploration. The demand for lunar exploration is going to be more in terms of near-Earth orbiting of the Moon and observations and also landers and so on and so forth. Certainly, the next phase could be related to communications, navigation and so on. But one advantage, the Moon of course, is the energetics of dealing with Moon in terms of a spacecraft is much less complicated, simply because, as was mentioned, the uncertainties on the lunar gravitational field itself creates a level of perturbation that it can, for example, in the case of Chandrayaan, we computed that from 100 kilometers, if we stop using propellant, in 160 days it goes directly onto the Moon. And so really you don't do anything to remove the spacecraft, it does it by itself. And 160 days is the kind of a life for a 100-kilometer orbit speaks of what kind of problems we could envisage if you were to translate that with respect to the Earth at the other side. So I think for the time being, these are not issues, but as was mentioned by my illustrious colleague, certainly in a part-term perspective, this need to be done, but by that time we would have got enough database of the environment of the moon, especially the asymmetries in the gravitational field and so on and so forth, which would enable us to make a better assessment of this issue.
Thank you very much, and that'll be the last word. I want to thank our speakers today, Dr. Kasturirangan, Nicholas Johnson, Dr. Sergio Camacho, and Dr. Caio Vischrogel. Thank you very much for stimulating talks and stimulating discussion. Thank you, the audience, for your questions and especially for your presence. Good day.